Hey, what's up, folks at home? I was watching Big the other day, and I wanted one of those big dancing pianos, and to dance with Tom Hanks a little bit, but we're gonna show you how to make one with an Arduino. Come on. Slid off the table. So to get up and running, we're gonna need a CUI 8-ohm speaker, an Arduino Uno, about 8 push buttons, a matching number of 10K resistors, and a 220 ohm resistor. And of course, a breadboard, some jumper wires, and if you wanna get fancy like I did, some cardboard or foam board. And if you don't have that many push buttons, you can follow along with just one. You can follow along with just one. Basically, the Arduino can be used to generate a square wave of varying frequency. Except it wouldn't be like this, it'd be like When a button is pushed, we tell the Arduino to generate a specific frequency. That frequency is made audible by connecting a speaker directly to the Arduino. So let's see how I built this big keyboard. First, with some foam board or cardboard, we'll need to measure out and make even cuts for 8 keys. Then, each of the push buttons is placed upside down on the bottom side of the keys with some hot glue. You'll need to bend the legs outwards so they sit flat. This way, the button makes contact with the floor when we step on the key. Next, I can solder on leads to each of my buttons and bring them back to a central location. We'll need to cut some proper length wires. Then, we'll need to connect those wires into the breadboard. Each switch needs 5-volt power, a 10K pull-down resistor, and a signal line to go back to the Arduino. The signal wires should be plugged into pins 2 to 9, and these will be our input pins. Within our code, we can tell each of these buttons to produce a different frequency square wave on our speaker drive output pin. To do so, the positive lead of the speaker must be plugged into an Arduino pin that can produce pulse width modulation. Pulse width modulation. PWM. PWM. Today we'll use pin 10, and the other lead can be tied to ground. I like it. It is cool! We don't actually need to vary the pulse width modulation of our signals. All of our signals will be 50% duty cycle, but we will use an Arduino pulse width modulation pin because the PWM functionality gives us an easy way to set the frequency. Keep in mind that each musical note is just a frequency. If this were a guitar string, the note would be the frequency at which the string is vibrating. This little speaker will produce sound according to the frequency content of the digital signal. It's a cool little speaker, actually. It's clear. You can see through the back of it. Because we are using square waves, the signal has harmonic frequencies in addition to the fundamental frequency. The sound would be much better with a sine wave, but the square wave will do just fine for our purposes. You can't hit 2 keys at once because it makes this weird sound. Our keyboard starts with note C5, whose frequency is roughly 523 Hertz. And the keyboard ends with C6, whose frequency is roughly 1047 Hertz. These two notes produce the same note, C, but the higher one is twice the frequency of the lower one, or as close of a frequency as the Arduino can produce. This factor of 2 difference in frequency is known as an octave. Using an oscilloscope, we can see the different frequencies that each note produces. You'll notice that C6 produces 2 cycles in the same period that C5 produces just 1 cycle. Anyway, within our code, we can assign each button a specific frequency to be played via the speaker on pin 10. Thanks to the pitches library, these notes already have specific frequencies, and it provides easy functions for controlling the Arduino keyboard. Functions. Why do I say it like that? Anyway, within our code, we can assign each of the buttons different frequency to be played via the speaker on pin 10. I'm using the most basic scale, which is C major, and consists of C, D, E, F, G, A, B, and C again. C, E, F, G, A, B, C. Here we tell the Arduino if C5 is pressed, produce a 523 Hertz square wave, or if G5 is pressed, produce a 784 Hertz square wave. The black keys don't do anything, I just added tape so I can visually see where all my notes are on the piano. Let's test her out.